Hello and welcome to this edition of Using R. In the next roughly a few slides of this particular slide deck, we are going to learn how we can read data in R. R is usually used as a statistical programming environment, which means that it's very well suited for complex statistical data analysis and even development of new routines and new ways of doing things. And you can certainly use textbooks to develop examples and other procedures using entirely R as your programming language. The first thing, though, for statistical data analysis is to make sure that you can read data into R. So in this set of slide decks, we are going to learn what are the different ways in which you can read data sets into R. And in this particular set of slide decks, we are going to focus only on reading textual data. And in a separate tutorial, I'm going to talk about how you can read what is known as data from foreign packages, although we are just going to touch this very briefly. And as you know, this is part of the e-Pathshala Karyakram of the Ministry of HRD and Education Ministry of India. My name is Arindam Basu. I am based at the University of Canterbury at Christchurch in New Zealand. And so this is about who I am. And here is a basic kind of the roadmap or learning objectives of this particular tutorial. When I began to write this, I thought that I would talk a little bit about reading data and then pre-processing the data and transforming the data and then summarize everything. But later on, it occurred to me that I think it would be a good idea to focus for this particular tutorial only on reading data rather than pre-processing or transformation of data. You will learn them eventually in course of this this set of tutorials, but because this is kind of one of the first things that we do, therefore when you start learning using R in all its glory for that matter, it is very important that you learn to read data first, and that's really, really important. And what do I mean by reading data? Well, if you think and reflect for a while in terms of what do we mean by reading, it's basically a sort of pattern recognition and understanding what it is that we are doing. So reading, for instance, from our early on, if you reflect back on your childhood days, for instance, you will see that by reading, what we meant was that we recognized a few characters, like A, B, C, D, or as the case may be in your native language. And then what you did was that when a text was presented to you or a picture was presented to you, you would read or you would comprehend that those glyphs and those pictures, those the meanings of those things, and you deduce this. So when we talk in terms of reading information in the context of a software or a kind of a programming environment such as R, the concepts are very, very similar. So you can take almost any object, convert that into a digital artifact, and then you can store it in a network or on another device or in a hard, a folder in your hard drive, and then you invoke R, and then what you need to do is, in some way, you need to bring that object into the R statistical programming environment. And that's what we mean when we say read something. So this is something that we're going to learn about it. but you will soon see that there are certain things that we also want to do in R. So it is a very good time to spend some time talking about those things. So as I mentioned, that there are essentially kind of 4 objectives of the lesson. The first objective, of course, is to explain very, very clearly that we should be able to read data in a number of different ways. And it'll soon become very clear that you can do certain things by way of reading series of numbers or texts or other things using the console, and I'll explain what I mean by this. It is very important when we read data into R that we should be able to edit that data. And in this particular tutorial, I would really like to emphasize this point a little bit. Now, yes, we know that R is a statistical programming environment, but most of us who use R in meaningful ways for our day-to-day data analysis, we use R as more like a statistical package, and it's kind of intuitive to use R that way. I mean, of course, you can read in data and then you can work with R in that sense and do things, but on a more regular day-to-day life, and particularly the purpose of this set of tutorials is not so much to show you how you can develop packages using R and a list of other associated languages, but to be absolutely honest, the audience that I have in mind, i.e., advanced students or students of statistics, or those of you who are going to do some data analysis using numbers and perhaps letters and textual data analysis, whoever that is, it is not unlikely that I think of you as individuals who are actually going to engage in manipulation of data, which means that you will be handling data, you will be reading in data, and you will be exporting data out of R, and you will be then transforming those data, and you will be working on the numerical data, for instance, or textual data, or image data, or voice data, or video data, as the case may be. Now, if you think for a while, if you step back for a while and think R in the context of a really beautiful statistical data environment, or statistical data analysis environment for that matter, other comparable packages, for example, the statistical analytical system, or SAS, or statistical processes for social sciences or social scientists, or SPSS, or STATA, all of these have got a very nice kind of built-in function that will let you not only to read in data, but also manipulate data within the same environment. And there is a historical twist to it, which we shall be discussing in the course of these lectures. That historically, when R was first framed, and R is only in its third major series of iterations, we are still on 3 dot something something. So it's not really all that old or well established. I mean, it's well established, but it's not that old. There was a bias that you could actually manipulate data outside of R. We'll revisit this. We'll visit this, but it was felt for a very long time that we should be able to somehow manipulate data, not just as an object, but be able to visualize them. So that required that R would develop a graphical user interface. And when you use the R's graphical user interface, then you should be able to invoke a graphical user interface to then edit and manipulate data. So this is why it's very important that we should be able to edit data into R, and we should be covering this as well. We should be able to read data from text files into R. This is very, very important because text files are very compact, very useful things that we should be able to do that. So essentially in this tutorial, we are going to cover that you will be able to read textual data into R and some very, very simple manipulation of that data by way of editing them. We will be looking at some other examples in some other ways, but here that's the thing. And the last but not the least objective, which is for which we have devoted an entirely new, a different tutorial for this, is that you should be able to read data from foreign file formats into R. So I'm not going to go into a great detail into what do I mean by foreign file formats, which will be dealt in another part of our lecture, but we'll see. This is very intuitive. That is, you got some numbers that you really would like to work on, and you would like to iteratively build up a data set, and then you wanted to, then you would like to analyze that. At other times, I mean, this is in the context of your own learning, but in another context, you may get a bunch of data that you'd like to actually ask people to load onto your own kind of machine. That is, you would like to actually ask somebody to type in data, which then you can go back and analyze yourself. While many of us are quite habituated to use actually data that is given to us in the form of paper and pencil, or in the form of a computer text file, it is not uncommon to actually leave up a console in which people would actually be typing data, or maybe you want to type data. And fortunately, and not fortunately, but it's kind of by design, R provides you such an opportunity because R has got a function which is known as scan. And scan is quite literally what it says. It kind of scans your console so that you can do whatever you like, which means that well, let me go to the code of the scan carefully and show you the nitty-gritty of it a little bit. So on the left-hand side of this screen, you're going to see that I have stored the result of a scan function into an object which is known as myVar. And myVar essentially is a vector, the way I have set it up. Because what I have done is I have used a function called scan, and then I have left the file space blank. So where you are seeing that there are two quote marks, you could actually input a text file and R would take it. But I wanted that R should, rather than use a text file to which I have inputted data and then read them up, because there are other ways in which R can more efficiently read files, I left it as at the level of a console. So I left it as a console, and then I have specified as to what it is that R is going to read. So it is somewhat intuitive. It is probably not very very academic, but you see that there is a parameter called what, and that what I have specified that it's going to have numeric variable in it, and I've closed that bracket. So in other words, I have closed that function up. So you can see on the right hand side, when I started running that particular section of the R script, it says that, okay, scan from the console, which is a blank quote unquote space, and R you should only read numeric data into it. And so then I've clicked enter, and immediately I find that there are like 5 or 6 lines come up. So till 5 lines I've kind of randomly punched in numbers, and then when it comes to the 6 lines, I've left it blank, I hit an enter, and then R understands that it has read 5 items. So on the left hand side you see a motif of a script which you can use. On the right hand side you see exactly if I could do it, how I do it. I mean, you could use myvar and then use a scan function. So in the object AX, R puts a stream of a vector of like 5 numbers. You can obviously understand that in another iteration I could have called it like Y scan, leave a blank, what, maybe text data, and it would put a text value to this. So over and over, repeatedly, I would be able to then build up a data set which I'd be analyzing. Or I could ask other people to put their names in it using a form or something, and then I'd draw in and put it into R. Okay, so that's one way of reading data into R from a console. But more commonly, though, we would like R to read a data from a plain text file. And when we say that R should be able to read data from a plain text file, what we mean is this, that there should be a string of numbers, texts, other forms of data sets which could be encoded digitally and presented in the form of a plain text file. The most commonly used plain text file would require that each of your data set, if that were to be coerced into a rectangular data format, would rather satisfy 2 things. One, your columns are going to specify that you're going to deal with any number of variables that you want to deal with. The second aspect of that rectangular grid of data that you will be working on would mean that your rows for such a grid would consist of your observations. So keep this in mind. Generally, when we talk in terms of a grid, we talk in terms of rows and columns. In this particular situation, your rows, each row will contain 1 observation. Each column will contain information on 1 variable that you want to analyze. This is the simplest representation of a square grid that you're going to analyze. There is a third understanding or assumption or a way of specifying what we want out of this is this, that each line, that is each observation, will end somewhere. So the new line will be a new observation, right? So that's how it's all arranged. There are different ways in which you can separate each individual quantum of information in such a rectangular grid. You can use a tab character to separate them, or you can use a comma character to separate them. In the world of data analysis, it is very common to use comma as a character to separate each quantum of information one from the other. Therefore, in each row, for each variable, you find that information is separated by insertion of a comma character. Such a file is stored in the form of a comma-separated value file. A plain text file, you create that file if you're using a Windows operating system, for example, in a simple program such as Notepad or a very simple notes feature, and all you need to do is just specify the observation, specify the variable, individual quantum of data, and you separate them using a comma character. And when your observation ends, you leave it in the form of a blank line. So the next line becomes your next observation, and so on. You keep that to a file, which is a text file, which gets a name called like a bod.csv in this particular case, like biological oxygen demand, for example. And then what you do is this, that you save that in a particular file, and then you will ask R to read that file. So when we want it, then we would ask R that R read the CSV file. And it is like, giving R a plain instruction in English, like read.csv. You can read a CSV file, R read.csv. But reading that CSV file, you do not want to waste it, because you would like to really to save the contents of that function into an object, which is my data in this particular case. And you save that into the object my data, which is like the data which you are then going to manipulate. And you have to specify certain things. The most important thing that you need to specify is you need to tell R that, look, R, it has got a header data here. So then what R will do is R will start scanning that file, and it will look for the first row of that file, and it will say that, well, that is a header row. So anything that goes into that first row, it is going to put it as if that is that are the variable names there. Very, very important. I know that it is not really very intuitive to tell R that the separator is a comma, because you could imagine that if R is so intelligent that it can read a CSV file, then it should know that it's a comma separator. But sometimes, you know what, you could actually separate them using a tab character, but you could still name that file as a .csv file. I mean, there is no reason why people should do that, but sometimes people do it. So it makes sense to mention very clearly that the separator is actually a comma character, or a tab character, or a dot character, etc., etc. Because sometimes it so happens that in some conventions, decimal points are separated by comma rather than a dot. So comma may not be a good idea to separate individual chunks of data. People use maybe a tab character. So that's the reason why you have to have a sep mentioned quite clearly. You can see that in this particular case, I have read the CSV file, but I've also decided to override the variable names. You can do that, because even though you say that, look, the header is true because it contains that, but you may not like the variable names. So what you'd like to do is then you'd like to read the ID and all of these things. Okay. So that's how you read a comma separated value file, and as far as possible, you should try to use a comma separated value file when reading files in R. The next thing that we would like to really emphasize here is that you can actually use R itself, that is the R program itself, to edit a rectangular data matrix. It's a very, very important thing that, as we have already discussed, for a number of reasons. R uses a GUI function, which means that if you use the if you use edit, it's as simple as that. So you take that object to which you have stored the contents of the file that you want to read, and then you order R that you would like to edit that object. When you do that, depending on your operating system and its configurations, R would like to invoke another graphical user interface, and that graphical user interface is based on kind of an X device in Macs, and otherwise a rectangular device that draws on your screen and then it is going to put something like a copy, paste, etc., which gives you a data editor. The beauty of the data editor is this, that it is exactly like a spreadsheet, like an Excel spreadsheet. So what you can do is this, that you can have the fine granularity of going into each individual data quantum, and you can then change that. You can change the name of the variable, you can change individual data point, you can edit it. When you are done, you can save the data set or you can quit it, and it is automatically going to save that data object. But the other thing that it does is this, that it kind of dumps everything into your screen. So one thing that you can do is this, that you can even save that edit function and store it into an object so that it does not dump anything to your screen, but just puts it back into the new data frame object that you would then like to work with. So that's why I say that when you close, the data will be saved. So in other words, if you just click quit, and then R is going to save everything that you've done to the data grid. Okay? Just remember that if you want to dump the contents, then dump the contents into an object rather than clutter up your screen. This is particularly useful if you're dealing with like thousands and thousands of data lines, because otherwise that's going to throw your kind of R console into such a disarray that you can't really make much sense of this. In the next, we are going to take a quick look at, you can use a code to read data from foreign files, but remember that I'm not going to spend much time on this. You can read foreign files into R. There's a whole tutorial coming up next for this. So essentially, it's a very, very short code that you can use. So like, if you take a look at this, you will see that you can, you need to put in a package, you have to install that package, you have to call the libraries, and they can read them. But for the time being, hold your thoughts onto this. But why did I then put this here? Well, the reason why I put this here is because I just wanted to make it quite integrative, that you can read data into R, right? So you can read from a console, you can read from kind of a text file, and I encourage you that you should always look for a comma-separated value file, which is the most widely used file format of data that are available on and off the web everywhere using CSV files, and you can read them. And to make everything complete, you're not really constrained by R only. You can read other foreign file formats as well. So that's the reason why I kind of mentioned foreign file reading in R, but it's not the main objective of this particular tutorial. So it's time to wrap up things a little bit, and let's quickly recap certain things that we want to do. It's a very simple, straightforward, highly introductory, but very, very focused tutorial. Remember that I would always encourage you, the analyst, to start thinking in terms of reading textual data in R or data directly from console. So that's the reason why I didn't go at great length in showing you all the varieties that you can do. Remember that you can use help and then put parentheses across and say read.csv, and R will dump you all the necessary information that you can learn about that. But again, the high impact points of this: always invoke, the read some sort of delimited file to get R. You can also use what is known as a read lines function for using data from R, line by line reading. You can read data into R from text files such as comma-separated value files. You can use a scan function to read file directly from console. You will see later when we talk about the foreign packages that scan has got another intelligent and clever use about reading files from Excel spreadsheets, for example, and from clipboard. And if you want to read really foreign packages, which we will be discussing later on, you can use the foreign package to read data from SPSS, Stata, and other software. So with these few notes, I'd like to really thank you for paying attention to this, and let's move on to the next topic. Thank you very much.